So it's quite weird.
No, this is okay. It's okay actually because they, as you notice, the system is not loaded heavily. So most probably, even the outages that you're going to have, it's not going to result in like any really overload conditions.
Really?
What is important here in the question is to show the process and show that you understand the process.
Okay, but that's so weird because we. Okay, so you think that's normal that if there's no line overload?
Yeah. Because as I'm saying the system is not overloaded. I mean, the load actual available in the system is lower, very low compared to the maximum, right? Maximum line limits and maximum generation point, right?
Yeah.
So even if you lose a generator or lose a line, most probably you will not have issues, most probably.
But how can we write, because there's a discussion in question 2 also, so if there's no line overload, then we would say that...
Say there's no line overload in your case, but just like explain more about why is that happening. So think about the load, the BD value, and the also the generation value, and also think about the line limits. So for example, if you have a line, if most of the lines are loaded, let's say 50% of their limit, and then we lose, and then some of them are 70%, it's not overloaded, right? However, if you have a scenario where you are already at, let's say, 95% loading, and then you lose a line, that might exceed the 100% point.
Okay.
So what you need, like, what more wording, what more description about it, saying that why you believe this is not happening, and focus more about the process. What's important here is the process more than the results. So make sure that the process is explained well. How did you do it and why?
Okay, so I want to tell you that what method that we're using at the moment. So we are using the SF from the textbook. So we calculated the new SF, and then we multiply by the data PI, and then we can get the results. Is that what we're doing right?
Yeah, this is fine. This is fine. Yeah.
Okay, so so then we finish question 2 then. We're just curious that because we review again and again, we find out there's no line overload, so we just doubt it. Like, do we?
No, it's fine. It's fine. That means you should not have no issues. Then you just need to think about why did that happen.
Because it's saying here, also saying that we need to discover via figure. But if there's no here, like the question is asking here, the solution from the 1.3 can maintain n-1 security, but if there's no line overload, then yes, it can maintain n-1 security.
Yes.
Oh, that's so weird. Okay, fine. And then
this thing, like I thought, like the idea of this question is to check the process, since depending on the system loading, you'll find like different results.
Okay. Could you
And also it depends on the hours. Remember that you are choosing 1 hour on your system, so depending on the hour. So if you choose an hour that's not loaded,
okay, so
then most probably,
yeah, so we can choose probably an hour that it's very heavy loaded, and we can say that there's line overload if we use heavy loaded.
It's not necessary, as I told you. If you choose an hour that's not loaded and you didn't get any results, any overload, that is okay, that is fine. So we will not deduct anything about, like, you will get the full mark if your process and your coding is correct. You'll get the full mark regardless of the result.
Okay, cool. Could you please, that's really, but we are up to this stage and we are not sure what happened next. Have you read?
Which question I talk about? This is question 2 or question 3?
Oh, this is not. This is question just an example question from the textbook. Have you read this one?
Okay, can you zoom in? I can't see. Can you zoom in a little bit?
Yeah. Just wait a sec.
Okay, so what is the question exactly?
So the question is asking, like, after we got the SF and then we got this distribution factors, and what we're doing next, we're trying to get the delta P in the line. But how to do the next stage? It's saying here that we need to multiply this distribution factor with the line flow. This one. So using this matrix times this value here, but the results here, it's not the same. So we're just confused. We are doing the right thing or not.
Mm-hmm. Okay. Yeah, I'm not really sure actually. However, like when you check it, like this one is the line or the flow on the line.
Yeah.
Right. Like, this is before that, and then you see the remaining lines, right?
Yeah.
So. It should work fine. Like I'm not sure. Like you just take that and multiply it, right? Multiply by the factor.
Yeah, just multiply the distribution factor with the line,
Yeah.
The previous. Okay, so probably it's something wrong here, but if you're saying that we just only need to multiply the distribution factor with the line flow.
Yeah, because the distribution factor is what is the, let's say, the link between like each line and also the let's say the lines, the other lines, right? So
Yeah.
it's a relationship between the lines and the body injection.
Yeah. Okay, so I guess if you're saying that it's okay if there's no line overloaded, then we can.
We can. It's okay. The hours that you put actually.
Yeah, we are confident saying that our results are right.
Okay.
And then to the question.
Okay, you just need to make sure that your report is actually well written, and so you don't just like put the short sentences. Try to write more and explain more in your report.
Oh, sorry, what? You're saying that we...
I'm saying in the report, try to explain more why is that happening.
Okay, because it's not heavy loaded.
Yeah.
Also, okay. And then the question 3.1, so the A, it just simply... Oh, let me show my code with you. So in the... So basically the 3A is using what we got from the question 2 and then just do it again, putting into a solver, right?
Yeah, but you need to include it in an optimization problem. So what is your optimization code?
Optimization?
Yes, a quad program. I mean, for question 3, question 2, you are not solving optimization. For question 3, you have to solve optimization.
How is that? So in the... Oh, yeah, but we are saying that because there's no like overflow, and therefore...
Yeah, but that doesn't matter. That doesn't matter. Your formulation does not care about your specific case. It's care about the whole system as a whole. Right? So you need to provide for formulation that guarantee that the system is secure regardless of the specific contingency.
Okay.
Did you check the hints that I sent for question 3?
Did you check the hints? Yes, the question 3, right?
Yes.
It's saying based on the question 1, but...
You start from question 1, but you add additional constraints. So it's question 1, you can copy the code for question 1 and add more stuff.
Yes, we do. So in question 1, we get a base solution, right? And then in question 2, we add this P loss.
Yes. You need to add in the constraints.
Yeah, and then we change.
I'm just wanting to turn on my iPad so I can just write on the screen.
Yeah, that would be nice.